Hello everyone, welcome to Mudgal Education. I hope everybody is doing very well, and myself is Ishan Mudgal, and this is my new initiative so that I can reach the multiple students from the electrical and EC background to share the knowledge that I have for the subjects that are going to come in your upcoming GATE and different state examination. So as you all know, if you are on this channel, you already know me, or you will know me after a few days when I will upload the videos regularly. So guys, we are actually doing for right now we are actually doing the basic and important concepts of a network theory, okay, which is one of the basic subjects you have. And once you complete this basic subjects, I'm pretty much sure many subjects like analog, communication, power electronics, power system, and I will say basically control system is going to be a much easier if you complete the network theory, okay. So what I'm going to do, I'm in the last class we have discussed about a network reduction technique. If you see the class just before this class, in that class we have discussed about a series parallel connection. In today's class we are going to discuss about the symmetrical concept in a network reduction techniques. So let's start our today's class. But before that, I will advise you to join my Telegram channel. The link is given in the description. Also, share the session among your friends so that more and more students can watch this video and get a proper knowledge from my content. Also guys, before going further, in a few days I'm going to launch my app in which you can see the paid courses also for the upcoming GATE examination, and I'm providing you a guarantee that in that course you are going to get the ultimate content for your upcoming GATE and other state examination. Okay, so let's start our class. So let me introduce myself. My name is Shan Mudgal. I have a 7+ year of teaching experience. MTech gold medalist from NIT Allahabad, 8 times GATE qualified, and these are my area of expertise. But I am pretty much sure that whatever question you have about any subjects, I can give you the answer for that. So don't forget to join my Telegram channel. Again, the link is given in the description channel, or you can see the name of the channel also. So can we start? Okay, so let's start it. So guys, earlier in the last class we have seen the series parallel connection of how to reduce a network. In today's class we are going to see the symmetrical concept. In today's class we are going to see a symmetrical concept. Most of you have heard about this concept and also have solved questions based on this concept in class 11th and 12th. The concept is exactly that you have read in a class 11th and 12th. There is no extra topic in it. But yeah, the questions that has been asked in a GATE examination are quite different that has been asked in your in the class 11th and 12th. So that's why we are learning this topic and then we will solve the question. So in a symmetrical concept, basically let me show you one particular diagram. Okay, let's suppose I have this diagram. Let's suppose I have this circuit diagram. Okay, I have this circuit diagram. This is a terminal A, this is a terminal B, and also I have this resistor. This is R, 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 and I will say this is terminal C, this is terminal D. Okay, now if I ask you what is the total resistance between AB, then 99% students will give me the right answer, because they will say ki sir, this is a Wheatstone bridge. Sir, it is a Wheatstone bridge, so we can apply the bridge method and solve it. Definitely well done if you have given the answer. But through this particular circuit, I want to discuss the symmetrical concept first. Of course, you can solve this question by Wheatstone bridge method. There is no problem. Now let's see this particular figure again in a different perspective. If you see very carefully, if I draw one vertical line here, if I draw one vertical line here, see very carefully. So can you see the mirror image on both sides? Can you see the mirror image on both sides? At this side as well as this side, the image is exactly the same. The network is exactly the same. So that is known as a mirror image. Also, if I draw one horizontal line, then again you can see above this circuit and below this circuit you have a mirror image. Mirror image means exactly the same circuit. So symmetrical concept is actually used in those questions in which at least one symmetrical line is present. What is a symmetrical line? This white line that I have drawn is a line of symmetry, across which you have a mirror image. If you see in this question, you have two line of symmetry, but if in the question at least one line of symmetry is present, we can apply the symmetrical concept. Okay, now symmetrical concept are basically divided into two parts. The first one is a mirror symmetry. The first one is a mirror symmetry. What is the meaning of mirror symmetry? If line of symmetry, LOS means line of symmetry, if line of symmetry is perpendicular, if line of symmetry is perpendicular to the axis of network, if line of symmetry is perpendicular to the axis of network, then we have mirror symmetry. Then we have mirror symmetry. Now the question arises, what is the axis of a network? Axis of a network means the particular line joining the terminals of a network. For example, in this particular circuit diagram, you can see if I connect the node A and node B, wait a sec. If I connect a node A and node B, here you can see this become the axis of a network. This become the axis of a network. Now if you observe carefully the line of symmetry here, which line of symmetry is actually a perpendicular to it? The first line of symmetry that we have drawn, this line of symmetry you can see a perpendicular to the axis, is perpendicular to the axis. So this line of symmetry is actually telling you the mirror symmetry. This line of symmetry is actually telling you the mirror symmetry. The second point, the second is folding symmetry. The second is folding symmetry. Now what is the meaning of a folding symmetry? Here, if line of symmetry is parallel, if line of symmetry is parallel to the axis of a network, is parallel to the axis of a network, then we have folding symmetry. Then we have a folding symmetry. Then we have a folding symmetry like this. Okay, easy concept. I hope you don't have any doubt. Then we have a folding symmetry like this. Now understand here why I have a two different kind of symmetry. If you observe again in this circuit, this particular symmetry is the folding symmetry, right? Now there is no need to identify whether you have a mirror symmetry or a folding symmetry if you understand the question by a simple common sense. If you understand the concept by a simple common sense, there is no need to identify whether you have mirror symmetry or a folding symmetry. So I will tell you the step-wise approach to solve the kind of questions in which you have a symmetrical concept. Okay, but we will see this question through some examples, because through examples we are going to solve question as well as learn the concept. So let's discuss the first question here. Let's discuss this question only. Let's discuss this particular question that you can solve using Wheatstone bridge. Okay, so let me draw the network again. Let me draw a network again, and of course you can solve this question using a Wheatstone. Again I'm telling you, this is just to explain you the concept. This is a resistor R, 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 this is a resistor R. Now understand the concept carefully. When you have a symmetricity, or you can say when you have a mirror image, you can see this is a mirror image. When you have a mirror, this is a line of symmetry. Okay, when you have a mirror image on the both side of a line of symmetry, the meaning of a mirror image means, for example, when you're standing in front of your mirror, what you observe that you can see the exact image of yourself, but the point is the left side become right side and the right side become left side. This exactly we understand in case of a mirror. The same thing will happen here. This is a point A, this is point B. So let's suppose this is a positive terminal, this is a negative terminal. Okay, now see very carefully, this resistor and this resistor both are mirror image to each other. So the amount of current which is flowing in this resistor, let's suppose I1, the same amount of current will flow in this resistor I1, in this resistor R. Okay, why? Because they are exactly the mirror image of each other. Okay, first point. Now this is the common sense that from a positive terminal the current will leave, and at a negative terminal the current will enter. This is actually a common sense here. Same case you can see for the resistor connected below here, the current which is flowing in this resistor, let's suppose I2, the same current is going to flow in this resistor because they are mirror image to each other. Okay, it means this I1 is actually flowing in this direction and I2 is actually flowing in this direction. So this resistor which is in between these two branches are actually does not play any part. So I can remove this resistor. So I can remove this resistor. So if I remove this resistor, the circuit becomes simplified. If I remove this resistor, the circuit becomes simplified like this. Now can you calculate a total resistance here? Now can you calculate a total resistance here? So let's see. RAB is equal to R and R are in series in both the branches and parallel to each other. Watch my previous class to understand the series and parallel concept. So 2R parallel to 2R, so it comes out to be R. So simple, RAB comes out to be R. Simple. So this is actually a mirror symmetry we have. This is bachcho actually a mirror symmetry we have. Understand this point? Understand this point? So I have solved this question using a mirror symmetry. Don't worry. You don't need to worry about which symmetry you have to use. I'm just explaining you right now. Once you explain the concept, I will give you a multiple shortcuts to solve the question, and that shortcut will be applicable to each and every question. Now the same I will use for the folding concept. Now what happened in a folding symmetry? Now for the same circuit, you can see if I have a line of symmetry like this, for a same circuit, if I draw a horizontal line, for a same circuit, if I draw a horizontal line like this, so this become a line of symmetry. This become a line of symmetry because here you can see the mirror image above this line and below this line. Okay. Now understand this point. When you have a folding symmetry, why it is a folding symmetry? Because to a terminal AB, it is parallel to the terminal AB. The line of symmetry is parallel to a terminal AB. Now, in a folding symmetry, what will happen? You have to fold the below part over the top part. You have to fold the below part over top part. To understand this thing, if I fold this above here, what will happen? This resistor will come above this resistor. If I do a folding here, both resistor R and R that I have encircled with the blue pen, both become parallel to each other. So can I say after folding, this become R by 2? Same for this resistor and for this resistor. If you providing a folding like this also become the R by 2. This also become the R by 2. But what about the resistor which is connected in between them? Now if you are doing the folding in here, you can see clearly that the half part of a resistor come to a top half of a resistor. So you can say again the resistor comes out to be R by 2. But the point is there is no connection here. Since there is no connection here, this resistor will not play any part in the question. And finally what we have left with this particular circuit. And I will say the resistance AB is R by 2 plus R by 2 equal to R. Okay, understand this point. In a folding, how we have removed the resistor, because when you providing a folding here, the resistor in between them have no connection to any of a circuit, have no connection to a remaining circuit. That's why this particular resistor can be removed, and the only resistor which has a complete connection will remain in a diagram. So if I say in a simple manner, in a mirror folding, what is a mirror folding? In which line of symmetry is perpendicular to the axis. So in a mirror folding, what you have to see? The flow of current. Okay, and the branch in which no flow of current is happening, you can remove that particular branch. In a folding symmetry, what you have to do? You have to have a line of symmetry parallel to the axis, and then you have to provide a folding, and the resistor which has no connection, or not only resistor, it can be inductor, capacitor, which has no connection, they can be removed. Okay, understand this point. Now apart from this, I will discuss one more question. Okay, there are multiple parts of this question, but after learning each and every concept, I will give you the shortcut. Let me tell you one more different diagram. Let me draw a diagram here. So let's suppose one more point. It is not necessary that each circuit will have both symmetricity. Some circuit will have a mirror symmetry only, some circuit will have a folding symmetry only. Okay, so it's not necessary. Remember this point. So this is R, this is R, this is R, this is R, 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 and I have a terminal A here, and I have a terminal B here. Okay. Now understand, I'm going to use a mirror symmetry here. I'm going to use a mirror symmetry. So if I draw a line here, now if you see this line of symmetry, why this is a line of symmetry? Because you can see the mirror image on both sides. Now this is a line of symmetry. Now this line of symmetry, this is actually a mirror symmetry we have, because the line of symmetry is perpendicular to the axis. The AB is the axis here, so we have a mirror symmetry here. So what I will do, I will see the flow of current. So let's suppose the current flow here is I1. This is a positive terminal, this is negative. So obviously the current flow here is also I1. The current flow here is also I1, because the mirror image we have. Now this current I am assuming is I2. Because of mirror image, this is also I2. The direction is like this because current enters the negative terminal. Now across this I can assume the current is I3, and here also the current is I3. Of course the current is I3 here. Now finally I will assume the current is I4 and the current is I4 here. Okay. Now understand this question. Understand this question. Every branch has current. Every branch has current, whereas in the previous question you can observe that the middle branch does not have any current. That's why we have removed that particular branch. But here every branch has a current. But the one point we can observe here very clearly, see very clearly this particular point, bachcho. One point we can observe here very clearly, that let's see the I2. I2 is flowing here and then flow in this direction. This is the flow of I2. Now let's see I3. I3 is going towards a node and then flow in this direction. This is the flow of I3. So you can say this particular node does not have any role. This is actually a false node. This is actually a false node. This is actually a false node. Why? Because the current I2, which is in this resistor, is going towards the upward side. It's not going to cross this particular node. So I can also simplify this circuit by removing this node. Now what is the meaning of removing the node? You can remove the node like this. You can remove the node like this. Here you can observe clearly, I have removed this particular node. I have removed this particular node. Now again I'm explaining you why I have removed this particular node, because see the direction of current I2 is coming from a resistor R and going towards the above resistor. It's not going towards any other terminal. Same goes for I3 coming from downwards going towards a downward. Again there is no particular resistor, there is no particular direction where I3 can go, right? Yes or no? Okay, see the I3, this is I3, this is I3. See I3, the laser pen. I hope everybody was able to see the laser pen. To see the I3, this is I3, this is I3. Now see the I2, this is I2, this is I2, this is I2. It means no current is passing through the node. So I can say that is actually a false node. So we can say that is actually a false node. Now if you have a false node, you can remove that particular node like this. Now this is a resistor R, this is R, this is R, this is also R, this is also R, this is also R. Okay, now it will become easier. What is the resistance of this? It is R parallel to 2R. What is this? This is R parallel to 2R, because 2R are in series. Again, what combination? So it comes out to be 2R by 3 if I'm not wrong. This is also 2R by 3. Now finally, what is a resistance AB? Both are parallel. So 2R by 3 parallel to 2R by 3. It comes out to be R by 3. It comes out to be R by 3. Understand this concept? Yes or no? Understand this concept? If you have any doubt, you can ask your doubt in a comment section. Also, you can join my Telegram channel and ask your doubts there also. Okay. Let me check one point. Then we will move further. Okay. Now if you want to solve this question by symmetricity, how you will solve this question, using a folding method. If you want to solve this question using a folding method, how will you solve it? Simple. Using a folding, let me draw question on another page. I'm drawing a same question. We will solve multiple questions today. Okay, we will solve multiple questions today. Don't worry. You will once you complete this video, you will get the concept easily, thoroughly, and then you can solve any question based on this concept. Okay, that's my guarantee. But you have to watch this video till the end and solve each and every question with me. So we have a resistance R. This is R. This is R. R. Now to apply the folding symmetry, once you have to check whether we have a folding symmetry or not. How you will check a folding symmetry? Draw a line of symmetry along the axis, or you can say the parallel to the axis. Now here you can see you have a mirror image on the above and below. Since I have a mirror image on above and below, what I will do, let's suppose this is line of symmetry. Wait a sec guys, there's problem in my camera. Wait a sec, just wait a sec. Okay, meanwhile try to solve this. I'm just checking my camera, don't worry about it, I will just coming back. But yeah, meanwhile you have to check, you have to solve this question. Okay, try to solve this one. Okay, so I'm going to turn off my video, and then try to solve it. Okay, don't waste much of your time. So see here, we have a folding symmetry, here. Now what I will do, I will fold this up with respect to this particular line of symmetry. Once I fold with this particular line of symmetry, what will happen? I have a circuit like this. I will have a circuit like this, and this. Like this, we will have a circuit. Like this. Now here we have R by 2, here we have R by 2, and here we have R by 2. Now here you can see R by 2 plus R by 2, because the below two resistors are in series, so it become R. Now finally, what is resistance AB? It is actually R parallel to R by 2, so it comes out to be R divided by 3. And the same answer we got earlier. So this question also solved using a folding symmetry. Okay, again, the name of symmetry is not important. What's the important? That you have understood how to remove a particular node or remove a particular branch. Okay, now I will lay down the steps here. So let's understood the stepwise approach. What is the step here? So first I will write down the step for a mirror symmetricity. This is a step for mirror symmetricity. Now again, what is a mirror symmetricity? In which the line of symmetricity is perpendicular to the axis. So the branch which is parallel to line of symmetry can be removed. The branch which is parallel to the line of symmetricity can be removed. This is for the mirror symmetry. So what is a mirror symmetry? In which the line of symmetry is perpendicular to the axis, that you have seen in this question, also you have seen in this question. So the first point here, if there is any branch which is parallel to the line of symmetry, in case of mirror symmetricity, can be removed. And the second point, if there is any false node, if there is any node lie on line of symmetry, then it is a false node. And can be removed. Simple sober step. Okay, now what is the step for the I will say the folding symmetry? What is the step for the folding symmetricity? To understand this also, what is the step for the folding symmetricity? Now the folding symmetricity, the step is, if the branch the branch which is perpendicular to line of symmetry can be removed. There is only one particular step we have. The branch which is perpendicular to the line of symmetricity can be removed. Okay, simple steps you have. Just you have to need to follow this step, or what you can do, you can see the direction of current also using the mirror image. You can also follow that particular step. So whatever step you feel is right, you can use that particular step and solve the question. The ultimate step is you have to solve the question thoroughly. The ultimate thing is we have to solve this question thoroughly. Okay, again, since there is some lag in my video, so I'm not able to upload, I'm not able to show my video. But yeah, if you have any doubt, you can ask your doubt in the comment section and join my Telegram channel. But still, we have many questions to do. So let's solve our questions right now. Now before that, let's discuss these steps one by one again. Let me take one more question. Then we will see the previous year question. Some previous year question. Okay, so first question we have. I'm advising you, each of you, kindly pause the video and try to solve this question. And yes, my drawing is somewhere bad. Apologies for that. Let me draw it again. So we have this particular network. Let me draw it completely, and then you can try to solve it. Also, you can play it forward and see the final circuit we have. Okay, so this particular network we have, and we need to find out a resistance AB. Okay, one more thing, guys, can you please provide me a feedback in a comment section, and you can also, can you tell me what improvement do you think I can do for you so that your learning experience will be good? Okay, so we need to find a resistance between AB. Each resistor here is of resistance R. You need to find out a resistance AB. Okay, now it's totally up to you what particular method you are going to use, the mirror symmetry or the folding symmetricity. That's totally up to you. In my perspective, the particular mirror symmetricity is much more easier as compared to the folding, but that's totally up to your perspective, nothing more than that. Now here I can draw a line of symmetricity. Now this is a line of symmetricity, and you can see this is actually a mirror symmetricity. Why? Because this line of symmetricity is perpendicular to the axis. Now in a line of symmetricity, before the step we have discussed the branch which is parallel to it. There is no branch which is parallel to the line of symmetricity. So the first point is going to be failed. The second point is, if there is any node lie on the line of symmetricity, then it is a false node. Now here you can check this node. This node lies on the line of symmetricity. Hence, this is a false node and we can remove. Also, if you forget this rule, then you can check the flow of current. For example, here the current is I1. So obviously, because of mirror image, the current here is also I1. Now here we have I2. Then of course there is a I2 here. Suppose the current is I3 here, because of symmetricity the current is I3 here. Now this is I4, because of mirror image it is I4. This is I5, because of mirror image this is I5, right? This is I6, because of mirror image this is also I6. And this is I7, this is also I7. Each and every branch have current. That's why no branch can be removed here. Now see very carefully. The current I3, see the laser pen. The I3 is going in this direction and going towards upward direction. It comes out below and going towards up. Okay, again I6 coming towards here and going towards below. Then I4 is going towards straight. It means this, but actually the node here is nothing but a false node. This node here is actually false node, because no current is going to cross this particular node. So we have a false node here. So if I redraw the circuit, by removing a false node, let me see. If I redraw the circuit by removing a false node, So what will happen? Wait a sec guys, wait a sec guys. Okay, so if I remove the circuit by if I redraw the circuit by removing a false resistance, false node here, then the circuit is like this. Then the circuit is like this. See very carefully. I hope you can able to see the circuit, right? Again, the video, I'm not able to show you the video because of some technical glitch, but I hope my voice is able to explain you the concept clearly. This is R, 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 R. Now the question is easier to solve. Now you can solve this particular circuit because the circuit becomes so much simple compared to earlier. Now here you can see, this is if you see the combination of these, what will happen? Acha, one more thing. Never apply both symmetricity together. Means, for example, if you think about it, can we apply the folding symmetricity after this step? No. You can only apply the symmetricity once. So only mirror symmetricity we have applied here. So here I can see R is parallel to the series resistance of 2R, right? So it comes out to be 2R by 3. Also this resistor, it's going to be add. So R plus 2R by 3 plus R. So it comes out to be 8R by 3. So the combination here is 8R by 3. This is also 8R by 3. This is actually 2R. So finally, what is a resistance AB? It is 8R by 3 parallel to 2R parallel to 8R by 3. So we can do the reciprocal sum. It comes out to be 3 by 8R divided by 1 by 2R divided by 3 by 8R. So 1 upon R AB, it becomes 6 or 4, 10. 10 R, it becomes 10 by 8R. Okay, there is no R in numerator. There is no R in numerator. So it becomes 10 by 8R. So finally we can say what is resistance AB. Finally we can say what is a resistance AB. It is 8R by 10, or I can say 0.8R is the right answer. 0.8R is the right answer. So this is actually a 2 marks question. This is actually a 2 marks question, bacho. So that's why you have to solve this question patiently and with this very with a full amount of your I can say that dedication, or you can say with a full amount of your dedication. Okay, any doubt in this question? So we can move further and solve the next one. Okay, again I have told you a common sense here also. I have told you what is the common sense approach, and I also gave you the steps. It's totally up to you if you want to use the steps or if you want to see the flow of current. It's totally up to you. Okay, whatever you want to use. Now let's solve another one more question. We can solve it using this concept. Okay, so let me draw. Okay, try to solve this question. Okay, we have R. In place of R, there can be inductor or capacitor also. In place of R, there can be an inductor and capacitor also. That's totally up to the I can say the examiner what they want to create in a network. Now here you can see. Bacho, what will happen. Try to solve this by yourself. So if you remember the steps, you can use the steps there. For example, I can draw a line of symmetry here like this, which is actually perpendicular to the axis. So I can say this is the mirror symmetricity. This line of symmetricity is actually from the mirror symmetricity. Now in a mirror symmetricity, we have already discussed that the branches which are parallel to it, can be removed. So this particular resistor and this particular resistor can be removed. So if you remove the resistor, then the circuit become like this. So either you can remember the step or you can see the flow of current that I showed you, flow of current method. So this is R, this is R, 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 R. Now the network becomes so much simple. What is a resistance AB? It is 2R parallel to 2r, parallel to 2r. So basically it become 2r by 3. Basically it become 2r by 3. Basically it become 2r by 3. Simple. Any doubt here? Simple. And if you have any doubt, you can ask. If you have any doubt, you can ask. Okay. Now can you solve some previous year question? So this is one question you can see on your board. Again, this is not a previous year question, but the question has been asked in the IIT JEE mains paper. So in this question, you need to find out the inductance, equivalent inductance across the supply if the total inductance is half Henry, 1/2 Henry. Now how to solve this question? How to solve this question? Again, that's totally up to you. If you want to use the mirror symmetricity, you can use the mirror symmetricity here. Okay, I will tell you, in my perspective, the folding method is much the mirror symmetricity method is much more easier as compared to a folding method. Now here what we can do, this is a terminal. Let's suppose this is a terminal AB. Now can I draw a perpendicular line here with respect to axis? Can I draw a perpendicular line here with respect to the axis? Yes, I can draw. So let me draw a perpendicular line here. This is a perpendicular line here across the axis. Here you can see perpendicular line there across the axis. Now again, use the steps I told you. If there is a branch parallel to the mirror symmetricity, this is a line of symmetricity in case of mirror symmetricity. If there is a branch parallel to a mirror symmetricity, then you can remove that branch. There is no branch parallel to it. Okay. And if there is a node lie on it, then that node is a false node. And here you can see this particular node is nothing but a false node. So if this is a false node, I can remove this particular node. I can remove this particular node, and our circuit will become like this. Okay, just don't mind my drawing, but our circuit will become like this. Yes or no? A, B. Now this is L, 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 because every element here is an inductance. Okay, L, L, L. Okay, now what will happen here? This is a terminal, this is a terminal. Now here again you can see L is parallel to 2L. Now I can see step by step. L is parallel to 2L, it become 2L by 3. Next, this L plus 2L by 3 plus L are in series, so it become 8L by 3. Now finally I will say what is LAB. It is 8L by 3 parallel to 2L parallel to 8L by 3. After solving it, you will get 8L by 10. 8L by 10. Now according to question, what is L? L is half Henry. So 1/2, it comes out to be 0.4 Henry. It comes out to be 0.4 Henry. So this is the total inductance we have. We have a 0.4 Henry as a total inductance in this particular question. Okay. Now this question, again, this is a question asked in a 2015 and a 1 mark question, because again it's a very simple question you have. It's a very simple question you have. So can we just solve this question quickly? You can see this is the axis. You can see this is the axis. If this is the axis, so can I say this is a line of symmetricity? This is a line of symmetricity. Since this is a line of symmetricity perpendicular to the axis, so all the branches which are parallel to it and the nodes can be removed. All the branches which is parallel to it and the nodes can be removed. So I can say like this, the current will flow in this direction, the current will flow in this direction, also the current will flow in this direction, or you can say the current will flow in this direction, right? Here also the current will flow from here to here, the current will flow from here to here. Okay, so this is actually a direction of current. Now I am hoping you can solve this question easily. You can solve this question easily, right? Yes or no? You can solve this question easily. So just remove the particular branches and see the direction of current. You can simplify the network easily. Okay, 1 mark question, so very much easier answer. Now let's see this question. Actually the particular circuit diagram is wrong. Let me draw the circuit diagram for it. Okay, just wait a sec. Let me draw a circuit diagram for it. let me draw a circuit diagram for it. Okay, so the question is like this. I have a resistor here, I have a resistor here like this. Okay, like this, and this is a terminal A and terminal B. So I have a resistor R like this. Okay, now let's see. Let's draw the line of symmetricity. Can I draw a line of symmetricity like this? Because I can see a mirror image across it. Now on this line of symmetricity, you can see this is a perpendicular to the axis, so this is a mirror symmetricity. So in this line of symmetricity, can I observe that this resistor, this branch is actually parallel? So I can remove this particular branch. Now there is no node that actually lies on this particular line of symmetricity. So only this branch can be removed. So if only this branch can be removed, I can redraw my circuit like this. So let me draw this. Okay, I know. I need to work on my drawing, on my writing also, so I know that. So just bear with me and we can solve this question easily. So we have like this, and that particular branch has been removed. Now the circuit becomes simple. You can solve it easily. Now how you can solve it? See very carefully. These two resistors become 2R. The bunch of these resistors is what? It is 2R parallel to R. So this becomes 2R by 3. Now this resistor and 2R by 3 are in series. So R plus 2R by 3 plus R. So it becomes 336, 8R by 3. Now finally 2R, 8R by 3 and this resistor R are in parallel. So I can say what is RAB? It is equal to 1 by 2R plus 3 by 8R plus 1 by 2R. 1 by R. So it become how much? It become 4 plus 8, 12 plus 3, 15. So 15 divided by 8R. So finally what is RAB? It is actually 8R by 15. 8R by 15. And resistance given is 1 ohm. Okay, resistance given is 1 ohm. So since resistance given is 1 ohm, so RAB comes out to be 8 by 15. So option D is the right answer. Simple concept. Option D is the right answer. Okay. Now next one. This is also a previous year question asked in both electrical and EC examination. So that's why it's one of the important question you have. So the question is, consider the circuit shown below with R1 equal to 1 ohm, R2 equal to 2 ohm and R3 equal to 3 ohm. That network is connected to a constant voltage source as given. Find the magnitude of a current through the sources. Okay, so you need to find out a magnitude of a current passing through a source. So of course, if you able to find out a total resistance, then you can find out a current also, right? Okay, so try to solve this question in your homework. This is the homework question. Give the answer in a comment section. Don't forget to do the homework. Also guys, join my Telegram channel. The link is given in the description. So we will end the session here. In the next class, I will bring the equivalent resistance of a 3D shapes like cube and cuboid, and it's going to be a very wonderful session again. So don't forget to watch that particular class also. Bye guys. If you have any suggestions, you can also put your suggestions in a comment section. But again, don't forget to complete the homework.